Hey guys, let's go ahead and start our next video. We're going to cover gravity, mass, and weight in this video. And so let's go ahead and get started. Alright, so the force of gravity, so we've talked about forces in our last video, and this is one force. And remember, it doesn't have to come in contact with something to affect something else. So it's a field force. So the force of gravity is an attractive force between objects. And the amount of gravitational force between objects depends on two things. And guys, when we talk about attractive force between objects, this is anything. Everything has an attraction, but it depends on two things. We have mass and we have distance. So let's look at a picture that will help us talk about that. The red arrows represent the force of gravity. So the longer they are, the larger the force of gravity is between these two objects. So if you'll notice, the first set of objects and the second set of objects, they're exactly the same amount of space apart. They're the same distance apart, but the second set of objects has a larger force of gravity, and that's because they have a larger mass. The larger the mass, the larger the force of gravity, or the larger the attraction they have. Now the ones up top, there is still a force of gravity attraction. It's just smaller than the ones below them. Now if you'll look, when we pull the objects even further apart, when the distance increases, the force of gravity also decreases. So the further something is apart, the less the force of gravity. The larger something is, the more force of gravity we have. Okay? Now, the force of gravity is different for each object in the universe. So like the Earth, the Moon, Pluto, all those different things, they have different gravitational pulls. On Earth, the force of gravity is 9.8 meters per second squared. So gravity is acceleration. I need you guys to notice that because it has meters per second squared in the unit. That means gravity is an acceleration. Alright, because a lot of times you'll see the words acceleration due to gravity and you're going to be confused at what it is, but now you should know that acceleration due to gravity on Earth is 9.8 meters per second squared. We call it also our gravitational pull. On Earth, everything falls at the same acceleration of 9.8 meters per second squared. A feather and a bowling ball will both fall at that same acceleration, but because we have air resistance here on Earth, they land on the ground at different times, right? The feather is going to be much more affected by air resistance than the bowling ball. So because of that, they'll land at different times. The further you are away from the center of the Earth, the less gravity can affect you. That is why astronauts appear weightless in space. They are so far away from Earth's gravitational pull that it doesn't look like they weigh anything, and they're floating. As you hike up a mountain, your weight decreases because you're moving further and further away from the center of the Earth, and gravity affects you less. So the higher up a mountain you are, the less you weigh. Now, it may not be an actual drastic difference in your weight, but there will be a difference. Now let's talk about mass and weight, because we were just talking about that our weight changes depending on location, right? Well, mass and weight, first of all, are not the same thing. That is one of the things that my students will get really confused about, and they will say that mass and weight are the same. So I want you to know that's a very common misconception, and you need to realize that they are not the same. Mass is the measurement of the matter in an object. So how many atoms, how many molecules make up the object? That's what mass is. Weight is the gravitational force an object experiences due to its mass. It's how much force we are applying to the Earth because we're being pulled down to the Earth due to the mass that we have. So weight of an object depends on location. So a change in an object's location will change the object's weight. We just talked about that. And weight is determined by gravitational force. So on each planet, on the moon, all those kind of things, we are going to have different weights because the gravitational force is different. Now let's talk about calculating weight. Our formula for calculating weight is weight equals mass times acceleration due to gravity. So whatever the gravitational pull is for that planet or object. Now, I've already given you in your notes an acceleration due to gravity chart so that you have some different planets and the moon and that kind of stuff for different calculations we're going to do. But you don't have to memorize those. They will either be given to you in the problem or given to you in a chart like this. And W equals M times G is how we will shorten the formula. And here's our circle, so make sure somewhere on your paper that you draw the circle. Remember, whatever we're looking for, we're going to cover up, and then it's going to show us what to do. If weight is over mass, we're going to divide them. When we need weight over gravity, we're going to divide them. If we have mass and gravity, we're going to multiply them. Now, this is what I'd like you to do. Remember, mass is going to be in kilograms for calculating weight, and acceleration due to gravity is going to be meters per second squared. I would like you to go ahead and do numbers 1, 2, and 3, and then pause the video while you're doing them. Resume the video when you're ready to check them. All right, I'm so sorry, I forgot to mention this before we paused it for our practice. Weight is measured in newtons because weight is a force. We talked about that force was measured in newtons. Weight is a type of force, so we also measure it in newtons. All right, let's go ahead and go to practice problem number 1. Let me get my Chromebook casting here so we can write. So for number 1, remember, whenever we're doing math, we want to do our 4 steps. So I'm going to go through those for number 1. And then for number 2 and 3, I'll just give you the answer. So number 1, how much would a person weigh? So that tells us right there we're looking for weight. So W question mark. How much would a person weigh on Earth if their mass was 150 kilograms? So mass, 150 kilograms. And to find weight, remember, weight equals M times G. So if we need to find weight, I need the gravitational pull or force of Earth. I can look down at my chart and know that the gravitational pull for Earth is 9.8 meters per second squared. And now I can calculate. I've already got my formula in letters. So now my formula in numbers. W equals 150 kg, kilograms, times 9.8 meters per second squared. And the answer that we get is that person's weight would be 1,470 newtons on Earth. 1,470 newtons. Now remember, this is not pounds. We measure in pounds here in America. And most people around the world would measure in kilograms or grams. But weight for science is measured in newtons. Okay, so this is different from pounds. All right, let's go to number 2. 2 asked, how much would this same person weigh on Pluto? So I'm going to give you the answer, but if you have questions when we come to class, make sure you let me know so that we can go over it. Your answer should have been 485 newtons. Now, I want you to look at something. Earth's gravitational pull is 9.8, and our weight right here was 1,470 newtons. Pluto's gravitational pull is 3.9, and that person's weight is now 585 newtons. So as gravitational pull decreases, weight decreases. As gravitational pull increases, the weight of someone will increase. Now let's look at number 3. And I'm going to go ahead and work this one out. So I'm going to go to another page. And it says a person weighs 342 newtons on Earth. So 342 newtons. What is the person's mass? So mass is our question mark. We need our gravitational pull. And it says that we're on Earth. So that's going to be 9.8 meters per second squared. And let's look at our circle. Our circle was mass times gravity on here and weight up top. If I'm looking for mass, I want to cover it up. We're pretending like it's not there because we don't know it. And that will give me my formula. If I want to calculate mass, I need weight divided by gravitational pull. So mass is going to be 342 newtons divided by 9.8 meters per second squared. And your answer should be a mass of 34.90 kilograms. That's our answer. So if you have any questions about these problems, please let me know in class, okay? Now we're going to go ahead. We have just a couple more things to talk about in this video, and then we will be finished for the evening. All right. Oh, I'm sorry. I should have put that up first. All right, so now let's talk about free fall, because we've talked about gravity, we've talked about mass and weight. Let's talk about free fall. Free fall is when the force of gravity is the only force acting on an object, that there's no air resistance, nothing else going on. So in the absence of air resistance, all objects falling near Earth's surface accelerate at the same rate regardless of their mass. We've already discussed this, right? So when things are in free fall, they're going to fall at the same acceleration. Now let's talk about projectile motion. Projectile motion is a curved path that an object follows when thrown, launched, or otherwise projected near the surface of the Earth. And projectile motion has two components, vertical and horizontal. And when the two motions are combined, they form a curved path. This is like when you throw a ball. When you throw a ball, it comes out of your hand, it goes up, and then it comes back down eventually, right? Unless somebody else catches it. The vertical component is the gravity pulling it down constantly, right? The gravity is trying to pull that ball to the ground, which is causing the path to be curved. The horizontal motion is you throwing it, your hand forcing it, right? The force behind your hand throwing the ball. And so that helps it go farther, but it's competing with that gravitational pull, so eventually it's going to come back down. And so that's it creates a curved path because both of these motions are combined and both at work. Oh, and there's my example, throwing a ball. So now what I want you to do is I want you to go ahead and, this is going to end tonight's video, so I want you to summarize. I would like you to summarize by, let's see, what are we going to do today? I think I want us to summarize by doing one thing you're not sure about, two things you have questions about, and three new things you learned. So let me go over that again. One thing you're not sure about, two things you have questions about, and three things that you learned from the video. All right, guys, I hope you have a great evening, and I'll see you in class.